do some practice problems to start the class here. So we got some old exponentials, and then we got a couple of logarithms there at the end as well.
Are we allowed to do this with a calculator?
You will need a calculator until we get to the logarithms.
Okay.
So all the exponentials will require a calculator, and the logarithms you cannot use a calculator. We'll pause it here for a moment. Okay. So we're going to have y equals ab to the x. We're going to use the 2 and the 19 as one value of x and y. So we'll get our 19 is equal to ab to the second. And I would put the bigger one, the bigger exponent on top. And think of it that way anyway. And so we can divide those two, and we'll get our 4/19. And then when you divide these, the a's drop out, and we subtract exponents, and we're going to get b to the third. So we'll get b to the third is equal to 4/19. We'll raise both sides to the 1/3 power, and I think we're going to get for b, what are we trying to get?
For B, it's 0.59.
Yes, I'm not seeing here. What should it be?
0.59.
595. And then once we know that, we can go back to either of the originals. And so I would pick probably the smaller one, and you can get a is going to be 19 divided by that b that we found to the second. And I think that's going to get us to a is 53.681. Is that right? Okay. Let's try the next one up here. We can give that a shot. Okay, so we're gonna take e to the 0.07 is equal to 1 plus r. Throw that into your calculator. You get 1.0725. Subtract off the 1. You have 0.0725. Make it into a percent. It's going to be 7.251% to 3 decimal places. Come on up. We'll do the third one. So we are going to subtract the 0.06 from 1 and get net 0.94 is equal to e to the k, or e to the x, or e to the r. Take the natural log of both sides, and then give your answer as a decimal. You can either say it's a negative 6.188%, or you could say it is decreasing by 6.188%. So we are going to start with our a equals p times 1 plus r to the t. And we're looking for the r. We know the t is 5. We don't know what we started with, but we know we're going to get 40% more than what we started with by the end of that 5 years. So we're going to end up with 1.4 times our original amount. So even though we don't know what that is, it doesn't matter because it divides out. So we get 1.4 is 1 plus r to the 5th. We'll raise both sides to the 1/5 power. We'll get a decimal on our calculator, subtract the 1, and make it into 6.961%. Okay. Similar problem next one, but it's a decrease. So we struggled a little bit with this one because it's a little different than the last one. Last one we said it increased by 40% over the whole 5 years. And so that was the result in the end, was the amount we started with increased by 40%. We were trying to figure out what that meant it increased by each year. Now we know what it's going to decrease by each year. So that's going to be that 1 minus 0.05. That's going to be over 10 years. And so we want to know then what ends up multiplying that p. And that, I think we got was like 0.5987 or something like that. So that was 0.5987. Now that is holding our 1 plus r. So that's the r. Now this r right now is the percent it decreased each year. After we've done that for 10 years, this is now the 1 plus r, where the r is the overall change over that 10 years. And so when you subtract 1 and make that into a percent, I think we got to, what was it, 40.126, is that right? So that's how much it actually decreased by over that 10-year period. So don't get rote and mechanical with it, kind of think your way through it there a bit. And see what we can do with the credit card problem. Now, a nice way that we talked about at first period was that this is 1.3% monthly interest. That is not 1.3% interest compounded monthly. So it's already given to you as a monthly interest, if that helps. So what we did was take here's our monthly interest. So 1.013 raised to the 12, that's how many times it's going to get compounded over an entire year, 12 months. And then we're going to subtract the 1 because we want the percent it increased over that entire 12 months, that year. And then when you make it into a percent, it's going to be the 16.765%. Now, in a similar fashion, this is now failing countries. Sometimes when the countries are falling apart, inflation just gets rampant. So I don't know in the history if you've studied like pre-World War II Germany, where the inflation became like thousands of percent in a year. So this is an example because this is now a daily interest. So see what you can find out for that annual inflation rate. So we have, this is our daily interest. It's not compounded daily. That's just the percent increase in price per day. So if we raise it to the 365 and set that equal to 1 plus R, the R is going to represent that annual inflation rate. And so it's ridiculously high because in this place the country is kind of falling apart. Okay, see if we can, without a calculator, answer the logarithm question. So we have a couple ways to conceptualize it. One is you can raise both sides as an exponent base 3. And then an exponent base 3 and a logarithm base 3 are going to cancel. And that takes you to the logarithm base 2 of x should be equal to 3 now, because that's 3 to the first. Then you raise both sides as exponent base 2, and the 2 to the third is 8. Alternatively, you can do like we do, you can say 3 to this power equals what's inside the logarithm. And then again, you say 2 to this power equals what's inside that logarithm. Either way, we're going to get to 8. Okay. All right. Do you need a hint on the last one, or? What's that?
Let's just do it.
Okay, we're going to give it a shot using your properties of exponents. Changing the problem there. This really should be logarithm base 5 of 2. Not logarithm base 2 of 5. So once I get the problem right, then we're going to write it as, we're going to make this addition in the exponent into the product of those two powers. And since 5 to the third is 125, and an exponent base 5 and logarithm base 5 cancel, so we just get 2 times 125 is 250. Questions on the homework? Any of those you need clarified? Good to go? Sandra, did you have a question? Or?
Yeah, can you go over question 45 on homework 31?
45. Page note, page that's on.
I don't.
It's on page, no, don't have to.
I think it was maybe 193 or something like that.
Okay. So would you know the problem if I said it? Oh, I think I know this, yeah, because somebody asked it in the other class. Log base 3 log of 3 times 2 to the x equals 8.
I think
Is
so.
that 45? Is that?
Yeah.
So we have log of, let's say 2 times 3 to the x equals 8 or something like that. Let me check again. 3 times 2 to the x equals 8, and they were talking about a, b, m, and n are constants, but I don't think that comes up in this problem. So we're trying to solve for x's the best we can.
Yeah.
So the trick to this, I mean, there's a couple ways you can do this. So what I would think to do is to think of the log of a product and use the property of logarithms. Other people might say, well, let's raise both sides as powers base 10 and get out of the logarithm that way. Either way, we can get there. So I'll let you take your choice.
I don't really care, because I think I tried both ways, but
Okay.
my answer was not coming out to be even close to what the book
Okay,
had.
so I'll do it both ways. I'm going to first do it. Now, the danger is we want to get to this log of 3 to the x, but we can't do it until we address this 2. So this is a log of a product. So we can write that as the log of 2 plus the log of 3 to the x. And this is still 8 on the other side. This is one way to do it. Now we can bring our exponent out in front. And so that'll become x times the log of 3 is equal to 8. Now, this is really just an algebra 1 problem. It's a number times x plus a number equals another number. So we'll subtract that over, call that x log 3 equals 8 minus log of 2. And then we'll divide the whole works by this, and we'll get 8 minus log of 2 all divided by the log of 3, and that's about the best we can do unless we're going to use a calculator. Alternatively, we could have gotten out of the logarithm right from the get-go by exponentiating both sides base 10, or thinking of 10 to the 8 equals this stuff. So that would get us to 2 times 3 to the x is equal to 10 to the 8. I would just leave 10 to the 8th as 10 to the 8th. It's going to be one with 8 zeros behind it. It's just kind of a mess to write around. Then we're going to have to divide by the 2 to get that by itself. Now we can take the log of both sides. So we're going to take the log of 3 to the x and the log of 10 to the 8 over 2. So now we get to use our property of logarithms and call that x log 3. On the other side, we have a log of a division. So we can use our property of logarithms to make that the log of the difference. The log of the numerator minus the log of the denominator. Now, this log of 10 to the 8, this is the logarithm base 10 and an exponential base 10. They're going to cancel each other out, and we're back to 8 minus log of 2. And now we're in the same place that we were a moment ago over here. So we're going to get to the same end result. And it's not pretty any way you look at it. And just the path we take there may be a little bit different. Okay? Anything else? Okay, well, make sure you got your calculator handy. Let's take a look at that worksheet. It's available on Canvas. So this is the notes worksheet 5.2. So you can see that the first problem there, we have city A starts with a population of 50,000. So city A starts with a population of 150,000, and it's growing
Oh, just
by
50,000.
Oh, 50,000, sorry. Thank you, 50,000. It's growing by 3.5% per year. Does that sound right?
Mhm.
And city B starts with 250,000, and it's going to increase by 1.6% per year. And so, of course, even though city B's got a big head start on population, city A is growing faster, so eventually it's going to catch up, and we want to know when. So we're going to write our corresponding exponential equation. So for A, shall we say A of t, the population of city A, is going to be, what's that going to look like?
Okay, so see, it would be 50,000.
Yeah, is Mace the only one out here that's doing this? Got to blink a little more often there, Anna. eyes dry out when you leave them open that long, staring off into space. So the initial amount's 50,000, and it's increasing by 3.5%. So that's going to be 50,000 times the 1 plus R, which is going to be 1.035 to the T power. Are we okay? Okay. B of T is, I think the weekend is coming here. That's going to equal 250,000 times 1.016 to the T. Now you can do, one way you can do this is to, like we talked about before, call this Y1, put this in your calculator as Y1, and this is Y2, graph them and see where they intersect. The problem there is these numbers are getting awful big, and these aren't growing all that fast initially. It may take you quite a bit of trial and error to figure out where they're going to actually intersect. So I'm going to show you an alternative way using logarithms, but it's kind of tricky. Okay, so we're going to set these equal to each other. So I'm going to say 50,000 times 1.035 to the T is going to be 250,000 times 1.016 to the T. Now, the tricky part here is we have two exponentials, and they have different bases, so we're going to have to resolve that. So our strategy is going to be, we're going to move the exponentials to one side and the non-exponentials to the other side. And then we'll have to do some thinking about the property of exponents. So I would rather divide the 250,000 by the 50,000. So I'm going to divide the 50,000 here from both sides. So I'm going to divide that out. And then simultaneously, I'm going to, since I'm moving the numbers this way, I'm going to move the exponentials to the other side. So I'm going to divide by the 1.016t to the other side. You with me there? So I'll do the division here. I can cancel the zeros, and 25 divided by 5 is 5. So 250,000 divided by 50,000 is 5. Can I write any of this time, or you just got a photographic memory here today, Anna? I don't think we're photographing anything, is my thought. So now we're thinking hard. We're squinting at that 1.035 to the T over 1.016 to the T, and we can kind of pull that out and write it as 1.035 over 1.016 to the T power. You with me there? Equal to 5. So we've maneuvered it into just one thing raised to the T equals that. And now we know how to solve this problem. How is that?
Because you can divide by, you can divide those and leave the log of those sides.
So we'll take the log. I won't enter that into your calculator just yet. Let's take the log of both sides. So we'll take the log here and the log there. And then we can bring our exponent out in front. So it's T log of that mess, 1.035 over 1.016 equals the log of 5. And then let's do this as one entry into our calculator. So we're going to take the log of 5 over the log of 1.035 over 1.016. And when you get that, why don't you give me about 3 decimal places? Think about what the units are on that. Anybody have it?
86.865 years.
86 point, what is it?
86.865.
865. Anybody confirming that? Not Anna. She is checked out for the day. Anybody else get it? Hello? Hello? Somebody out there?
Yeah, I got it.
Oh, thank you, pal. And that's going to be in years. Somebody make some loud noises out there once in a while. Okay, you got that one?
And
So-
that's when they equal the same.
That's when they will equal the same. They'll have the same population. And then from that point on, City A is now past City B, and it'll have the larger population. theoretically, unless a pandemic or something hits. What's the likelihood of that? Okay, so let's look at the doubling time question, okay? So we have the turtle population is given by P of t is 175 times 1.145 to the t. And I'm going to ask you some questions on that. This is good because you don't have to do anything, so Anna may participate in this part. What is the initial population of turtles?
175.
Good, so our population at time 0 is 175. And what is our growth rate?
14.5%.
14.5%. There's just not enough time in the day. Okay, so if you need some help on this, there is a support video on the module there in Canvas, and it works through all of this. And so that can then maybe help you with your homework.
It says every other odd, would that be 1, 7?
So whatever it starts with, I don't know if it starts with 1 or 3, because sometimes I'll mix it up.
Yeah, it starts with 1.
So you start 1, skip 3,